Greetings, Earthlings. Today we're going to take a look at this Transistor Devices DLR 50-15-150A electronic load. This is a device that's used for testing things like power supplies and stuff like that. It has several modes. It has a constant voltage mode, a constant resistance, constant current, and it has an external modulation mode, which could be used, say, if you were wanting to test a battery, say you had a battery charger that you wanted to test. And so batteries, when you charge them, the current that they draw is not constant, nor do they look like a constant resistance. So you could have an external device that provided a modulation signal to this thing that could model the battery charging circuit, or the model, using this to model the battery so that you could test your charging circuit. The 50-15-150 means that it can take up to 50 volts, up to 15 amps, but combined 150 watts. So it's got a fan in it. It makes some noise. We'll power it on. And so then I have a power supply here. You've seen this before. I have the Tektronix multimeter, because this can actually show two readings at the same time. So I can show DC volts on the main scale and DC current on the alternate scale, secondary scale. So that will be fun. These things have fans, so as I power it up, it's going to start making a bunch of noise. We'll put it down here. I currently have it set here on constant current mode, so so I can turn that on, and let's see, I have that all the way down. So this is the adjustment for the current. So if I turn it on, we can see it reads about 5 volts here on the voltage scale. Well, that needs to be calibrated. 4.9996 and basically no current. And I've got this on the 6 amp scale, so meter readings 1.8 amp, 6 amp, or 18 amp scale. The 1.8 and 18 are that lower scale. The 6 amp is the upper scale. Since I had this set to limit at 5 amps, which is all this thing can put out, we're going to read it on the upper scale. And then 0 to 6 volts is on the upper scale. And reading's a little off, so it'll need to be calibrated. But I'm going to give it some current now. So turn that up. So that's reading, well, that's reading about 2 amps here. This is reading 2.257. This is reading 2.261. Nobody agrees. But again, it looks like both the voltage and the current are reading low on this thing's meters. These agree pretty close. So let's get it up to 5. There you go. See, 5 amps. This kicked in, the current limiting kicked in here. So we've got 5 amps. This thing 4.997, that is saying right on 5. 1.6 volts, yeah, whatever. So they're at about 4.8, 4.9 amps. You can see it hasn't kicked in yet. That's where it kicks in right there. Yeah, and at 5 amps, you know, I don't know how much loss there is in these leads. They're probably not used to taking 5 amps. It's probably not sized for, say, 10 amps of current. So, yeah, that's, if I limit it here at 1 amp, then I'll go down to that scale. And similarly, you know, like what we saw before, 5 volts. Well, actually, I want to go down here, 0 to 3 amp scale. Is this on? This is not on. I did not turn that on. Okay, 5 volts. We're on this lower scale now, so let's read 1.8 amp. 1 amp is around there. Stop it there. 0.708, 0.712, that's all pretty good. 4.97, 5. You know, this has never been accurate. This seems a little more accurate. We're assuming that this is accurate. And there we are at 1 amp. That's saying, yeah, we're spot on 1 amp. That's saying right on 1 amp. This is, again, reading a little low. We go to a higher voltage. Let's see, switch that off. We'll switch this up to, oh, come on. Let's go all the way to 30 volts. Which is as much as this can do. So we're on the 60 volt scale here. And 1 amp. Yeah, that'll be fine. 30 volts would be there. 29.962, yeah, but that's still reading a little low. Get it to about half an amp. That's just 506, 5117, yeah. Well, that's interesting. This thing, you can hear the relays clicking in there as it brings the voltage down to a point where it is properly current limited. Okay. So that's all well and good. So yeah, like I said, this thing, I didn't say, I just bought this off of eBay. So this is a first look at it, and it does seem to be working. Hooray, hooray! Except it needs good calibration. Yeah, the other thing I want to do with it though is remember these from the here. We'll put them there. From the Heathkit frequency counter, LM309Ks. They had some weird behavior, which caused me to put in a higher powered regulator. But yeah, I want to play around with these and see what kind of behavior we can see. I suppose I could, before I do that, let's just demonstrate constant resistance mode. Constant voltage, I think in the manual it says that that this then acts like a high-powered Zener diode. You could use it as a shunt voltage regulator. So on constant current mode, what we saw is no matter what voltage we put in, let's set it at like half an amp. Okay, that's close enough. And then I can go in and I'll vary the voltage. Bring that down, and you see it stays drawing half an amp. Until I go to nothing. if I were to go, I'm going to switch that off. If I were to go over here to constant resistance, then let's bring it back up to 30 volts. I said let's bring it back up to 30 volts, and I'm going to take and I set it to half an amp at 30 volts. And that's close enough. And I bring it down, we'll see that the current that it draws, you know, at 20 volts it's 0.3 and so on. So at 10 volts it should be a third of half an amp. Yeah. So that part's working as well. Okay, so here's the setup for testing the LM309K. There it is there. I've got 8.3 volts in. I think that's what the unregulated voltage on the Heathkit was, approximately. I'm limiting it to 1.5 amps here, just so we don't blow anything up. That comes out of there into there. 5 volts out is going to the load, and I have the Keithley measuring the voltage at the load. So this is set right now to about 0.9, what was it, 0.96 amps or something. It's how it switched off here. If I switch on, well, if I turn the power on here, we get 5 volts, no current. We're gonna trust this to be close enough that we don't need that Tektronix meter at this point. Okay, if I now switch on to constant current mode, that dropped a little bit, but it's still at 5 volts, 9.977 amps. Okay, so just under an amp. Seems fine, right? Why wasn't it working before, you know, in that circuit? Well, here's something I discovered. I'm going to switch that off. This is a DC. I don't know exactly what this does, but watch when I switch on. 0.76, 0.67 amps. Something about how it switches on. You see, if I switch on this way, it's fine. If I switch on this way, it exhibits that same behavior that we were seeing in the other circuit. Now I'm curious if this will correct itself at a lower current level. There we go. Okay, so now I'm at, let me go to half an amp. Close enough. Off. On. No, it doesn't like that. This is weird. It doesn't seem to matter where until I get down clear to 0, or very close to 0, that it, okay, so there, 0.01 amps, yeah, let's go like, oh, okay, let's try it there, it's okay there, 40 milliamps, oops, 48, let's try 100. No, at 100 milliamps, it doesn't work. At 88, yeah, at 90 it works. At 100 it doesn't. So something about, well, no, there it didn't work at 86. Oh, 86. Oh, well, now this could be, no, I don't know. I don't know what we're seeing here. Doesn't like it there. It's okay there at about 50. So anyway, there's something about how you power on, you know, what the load looks like at power on to those LM309Ks that causes them to go into that weird, what do you want to call it, state, you know, and I don't know, I don't understand what it is, but I mean, I fixed the problem in the Heath kit, so I'm not going to worry about it too much. Although I wonder how many other Heath kits exhibit that behavior. Clearly, there's something about these 309Ks, but I don't know if there's a consistent something about those Heath kits, you know? Oh, and the other thing, the LM309K can deliver more than 1 amp. Okay, here it's drawing 1.2 amps, and you see it's still regulating just fine, I would say. Don't want to leave it there too long because it's probably getting warm, toasty. Oh yeah, that's hot. So anyway, that's where it's at. That's your Transistor Devices DLR 50-15-150A.